Hello again, Algebra 1. This is your Q4 Week 2 examples video. So if you haven't already watched the vocabulary video, make sure you watch that one first. So this week we are talking about linear functions IRL, linear functions in real life. So hopefully this will help a lot of you as we are trying to connect this weird thing called slope-intercept form with what does it actually mean and why do I even care. So we're going to start with a relatively simple example. So we're going to look at this equation, y equals 20x plus 10. So let's think back to slope-intercept form. It says y equals mx plus b. We know m is the slope. We also said we're going to start calling this the rate of change. And b is our y-intercept, or our initial value. So how can we interpret this equation with our numbers in it using these ideas? So let's think about it. What this situation says to me is I'm going to turn it into like a word problem. So I think its rate of change is 20. 20 is increasing because it's positive, so something is going up by 20 every time, and it starts out at 10. So when I made this equation up in my head, here's the scenario I said. I have $10 saved each month. I will save $20 more. So I can use this equation then. X is going to be the number of months. And y is going to tell me how much money I have. So if I just start, my number of months is 0. I don't have anything other than $10. I can plug 0 into here and prove that. So let's get a little bit of space where we can write. Okay, better. So we said I start with $10 and every month I save $20 more. So I think about my initial value is this 10. And so that's like time is 0. I haven't started saving money yet. So if I plug in 0 for my x, so I say y equals 20 times 0 plus 10, I should get the thing that I start with, my initial value. So let's see. Y equals 20 times 0 is just 0 plus 10. So 0 plus 10, y is equal to 10. So the amount of money I have after 0 months is $10. That's what I started with. If I say, I want to save money for a year, how much money am I going to have? Well, how many months are there in a year? 12. So let's plug in 12. So y equals 20 times 12 plus 10. So 20 times 12. 10 times 12 is 120, so 20 times 12 is 240 plus 10. So after 12 months, I should have $250 saved up if I'm saving $20 each month. If you want, you could count 20 plus 20 plus 20 12 times, but that's what 20 times 12 does for us. If you wanted, you could count it out and prove that this is correct. So I always think it's a good idea to relate these equations to money because it's an easy way to understand it. Everybody likes money. Everybody gets money for the most part. So let's look at a different but similar example. Let's get a little more space down here. So let's say this is in the before times, and you really like going to Mr. G's neighborhood groceries to get snacks every day. So let's say your grandmother gives you $50. So $50 from grandma. And every time you go to Mr. G's neighborhood, you spend about $4.50. Like you added it all up and you did an average and you did a lot more math than we're going to do in this video. And you figured out $4.50 each trip to Mr. G's. Well, how many trips can you make before you're out of money and you're having to borrow some money from your best friend? So let's put this into an equation. Y equals 50. I'm going to do this a little bit different. So let's actually not do 50 first. Let's say, what am I doing each time I go to Mr. G's? So my rate of change, in this case, my rate of change is how much money I'm spending. That's the thing, that's how much money I have is going down by $4.50 each trip. So if it's going down, is that positive or negative? It's going to be negative. So minus 4.50 each time, so that's X is going to be the trips you go. And then I started out with what? What was my initial value? How much money did I originally start with? $50 plus 50. So I can use this equation to figure out how many times am I going to be able to go if I'm going to use all my money. Or I can figure out, hey, I'm going to go every school day for 3 weeks. That's going to be 15 school days. So how much money would I spend, or how much money would I have left? Both of those are important things to think about. How much money would I have left after 15 days going to Mr. G's? So y equals negative 4.50 times 15, because X is the number of trips I make, plus 50. So we need to do $4.50 times 15. So y equals negative $67.50 plus that $50 that I start out with from grandma. What do I have? Well, if I do negative $67.50 plus 50, I'm going to get negative $17.50. That means I've had to borrow $17.50 from my friends to buy snacks from Mr. G's. So maybe I should cut back a little bit on the Mr. G's trips here. So going back to our ideas that we are talking about, what is our rate of change? Well, rate of change in this problem is the thing that's each time. That's what's happening each time. It's changing each time. So our rate of change is negative 4.5. What is our initial value? Initial value. What do we start with? We start with $50. So, looking at this is basically a word problem. I just didn't write it out first. We just started talking about it. So we can do any word problem like this that's set up for linear equations. So, got $50 from grandma. Each trip I'm going to spend $4.50. Put that into an equation. Then I can use that to find out different things. So what you're going to do this week is I'm going to give you a couple of word problems, and you're going to try and write equations that match these word problems. So again, if you get stuck, have any questions, please make sure you email me, and hopefully I will see you on Zoom soon.